Sorry to interrupt your conversations. They're probably a heck of a lot more interesting than you know how. But it's Wednesday. That's cool. Yeah. I hope you all had a decent day yesterday. I started work yesterday with an 8:30 meeting and didn't get off campus till 7:30 last night. So I slept really well. Oh my God, so many people. So anyhow, what I want to do today is continue with some examples on Venn diagrams. And I also have some announcements that I'm going to make. I will be sure to make them earlier so that everyone can catch them. I know that some of you have classes over on the mountain campus right after this. And so I understand that sometimes you need to leave early in order to get there, and that's totally cool with me. I just want to, and so I appreciate you letting me know, because then I can make my announcements and be sure that everyone's in the loop. So, other thing, and I forgot about this yesterday. Some people did ask for a hard copy of a syllabus. And I made about 15 to 20 copies. If you want one, you're welcome to pick one up before you leave today. And if I don't have enough, boy, it sure doesn't take much for me to go print them and bring them to class next time. Okay, but I did do this, and I apologize for spacing that out yesterday, but it was kind of like a Monday, so I can't do it, right? So, I guess what I would first like to ask is, does anybody have any questions about anything that we talked about yesterday? No? All right, so I don't know if that's a good sign or a bad sign. Maybe no questions means it doesn't, that you haven't looked at it, or perhaps it's clear to you thus far. But I just want to encourage you, and I know that it will start once I start assigning homework, that questions will arise. And again, I just want to reiterate that I love questions. You've got to ask any and all questions that you have. It's really my goal for everybody to be successful in this class and learn the material, and asking questions, I believe, is quite essential to get there. So please don't be shy as they arise. Cool. Awesome. All right. So if there's no questions, what I'm going to do is pick up where we left off yesterday. If you weren't here yesterday, I encourage you to access the box folder to get the class notes and recording, because I pick up essentially where we left off. So there is the assumption that you were here, or that you accessed the recording prior. All right. So I had promised you, not that you necessarily wanted it, a 3-circle Venn diagram that we fill in and then answer some really interesting questions about. Okay, as you may recall, something that I mentioned yesterday, there's really 2 different skill sets going on. One of them is being able to take all of the information and put it in a Venn diagram appropriately. Okay, that's one skill. Another skill that is separate from that is, given a filled-in Venn diagram, do you know how to read it and answer the questions that follow? Okay, so as I mentioned yesterday, when I asked the question, notice I said when, not if. When I ask a test question that requires you to fill in a Venn diagram and answer questions, my advice to you is, if you forget how to fill in a Venn diagram, make up numbers, okay? Because I grade the questions that follow based upon the numbers in your Venn diagram. It's a way to maximize the partial credit that you get. And I like to give people cost-taking strategies in that regard. Okay, so if you can fill in the Venn diagram perfectly, sweet, then answer the questions. Okay, if you make a mistake filling in the Venn diagram, yes, you might lose a maximum of 4 points, which is really a trivial number on a test. But if you answer the questions correctly based upon your Venn diagram, you'll get full credit from there on. Does that make sense? Cool. Okay, so let's do it. Aren't you all excited? Okay, so suppose 100 people were surveyed. And I will say that they were surveyed and they asked if they like to do particular activities, okay? And I'm kind of being, I don't want to say self-centered, but I'm writing down 3 of my favorite activities. So suppose 50 people like to run. 30 of those people like to swim. And 35 of those people like to bike. Suppose 14 of the people, and I'm going to call run R, swim S, and bike B, because I'm just that creative. Okay. So suppose 14 of these people like to run and swim. 9 of these people like to run and bike. 7 of these people like to swim and bike. And 3 people like to do all. Okay. So what we want to do right now is fill in the Venn diagram. Okay. Again, the same ideas and techniques that we used yesterday, we're going to continue today. Key thing to remember, like if you remember nothing else, and you get a sheet of paper with notes on your test. So, this is a key thing to remember. Start inside and work out from there. No pun intended there. The good thing about a math class is almost anything seems funny because math tends to be dry to people. So my sense of humor or lack thereof is okay. All right, so what we want to do is fill in a Venn diagram. Now, on a test, I will have drawn and labeled the circles in your Venn diagram, and you see like my lack of artistic ability already. But what we want to do is name each circle accordingly. Okay. Now, this whole entire thing is my universe. Notice my universe consists of a lot of different regions now that we've introduced another circle. Okay. So some things that I want to comment on. These people out here matter. Okay. They are the people who do not like to run, nor bike, nor swim. Okay. These people right here, of the 3 activities, only like to run. Okay. Again, I'm focusing on this so that you start identifying the regions of the Venn diagram using the terminology. What I'd also like to point out is these people right here in this wedge, these people like to run and swim. Okay, these are the runners and swimmers. But notice that consists of 2 separate regions. Okay, these people right here like to run and swim, but not bike. Whereas these people here like to run and swim and bike. Does that make sense? Okay, we're being very literal about where these things overlap. So another way you could talk about this particular region right here is this is run and swim only. Okay, that's equivalent in this context to say run and swim, not bike. Questions there? All right, so where do we start? Innermost region. How many people like to run and swim and bike? 3. Notice something else that I want to point out. You can't just put 50 in here for run, okay? Because the runners comprise this entire circle, okay? So I know that this plus this plus this plus this needs to add up to 50. So right now we've accounted for 3 of those 50 people, okay? Does that make sense to everybody? Cool. So I always put a little check mark so I can kind of keep track of my work. Okay. Now, 7 people like to swim and bike. Again, the most common mistake people make is they just put a 7 out here now. But you can't do that. Otherwise, we're double counting people. Okay. Swim and bike is this entire wedge. And this entire wedge needs to add up to 7. How many of those 7 have we accounted for? 3. Therefore, how many go here? 4. You'll notice that the questions that I ask are the same. And again, I don't mean to sound redundant and repetitive, but I want you to start asking yourself these same questions. The thought process is what's really important. All right, if anyone has a question, just yell out. Or if you're on Zoom, unmute or put it in the chat. Okay, 9 people like to run and bike. Do you agree that this is my running and biking? Okay, how many of those 9 have we accounted for? 3, so how many go right here? 6. Do you see how this is following the same sort of procedure? Okay, again, the most common comment I get is, I totally get it when I'm in class and you're doing it, but then I go home and I'm totally stuck. And so the whole idea here is that I want to help you and help guide your thought process. All right, 14 people like to run and swim. That is this entire wedge. How many have we accounted for? 3. And therefore, how many go here? 11. Awesome. So now let us go to these first 3. I just like working my way up. 35 people like to bike. This is my cycling circle, okay? And I know that this entire circle has to add up to 35. How many of those 35 have we accounted for? 13. And therefore, how many would go here? 22. Cool there? All right. 30 people like to swim. That's this circle right here. How many of those 30 have we accounted for? 18. And therefore 30 minus that 18, AKA 12, go right here. Notice I'm not just shoving numbers in. I'm taking my time and thinking through the process. Second to last, but not least, we have 50 people who like to run. Thus far, how many people have we accounted for? Well, we have 20 people thus far. And so how many people go in my runners only? 30. Am I done? No, we've got to talk about the people who don't enjoy these activities. Okay, so how would we do that? Yeah, this is kind of where it gets to be a little bit of a pain. We've got to add up all of the numbers that we've accounted for. And then we would subtract it from the total of 100. So what I tend to do is just start with the biggest circle. I mean, yeah, you have calculators, but you got 50 here, and then you add on 4, so 54, 56, 66, 76, 86, 88. So we have now accounted for 88 people, although 100 people comprise this entire survey. So we would get 100 minus 88, AKA 12 out here. Isn't that cute how it just kind of unfolds? Thanks, I think so too. All right, questions this far? Okay, well, now that we've filled in this really thrilling Venn diagram, why don't we answer some really thrilling questions? How many people? And right now, what my questions focus on is, do you know how to distinguish between the different regions of the Venn diagram? Okay, so what if I ask how many people like to run but not swim? Notice biking is not mentioned here. We could care less about where this stuff intersects my B circle. What I'm interested in are the people who like to run but not swim. So how many people would that be here? 36. We have these 30 plus those 6, which gives us 36. Are there questions? Okay, what if I say only like to run and bike? Well, here's my running and biking wedge, but now I'm talking only. Yes?
They like to run but not swim, but that can mean that like everyone else that's not like specified.
Well, if they like to run, aren't I totally limited to this circle right here? Because these are the only people who like to run.
But not swim.
And then the not swim is we want to cover up anything that intersects my swimming circle. Thanks for asking. You're cool. And being told that by a math teacher really has a lot of. All right, good. This is only 6. If we're talking about running and biking, that's this wedge, but notice I said only, so we can't count these 3 people. What if I want to know how many people like to run or bike? Now, what region of my Venn diagram am I talking about? Notice or means union. Okay, we don't want to forget that. Well, here's runners and here's bikers. So which regions are we talking about? I claim it's everybody in my running circle. So 30 plus 11 plus 6 plus 3. And now, don't I need to add on the other people in my biking circle? Okay, which is another 4 and 22. So we get 76. Okay, again, I claim these 2 regions right here, this 12 and this 12, are the only places that contain people who don't like to run or bike. Okay, remember, or means just put them together. All right, what if I say bike or swim? Now who are we talking about? Isn't it everybody in my swimming circle and my biking circle? So all but this 30 and 12? Yes, no? Okay, so I claim you're going to get 58. You with me there? All right, ready for some more really thrilling questions? What if I want to know? Okay, I'm getting really nitpicky with my language, but that's cool. It's good for us. How many people like exactly one of these activities? How would we determine this? Good job. The way we can translate this, if they like exactly one, it's only running or only swimming or only biking. Does that make sense to you? What if I asked how many people like exactly two of these activities? Now, which regions are we talking about? Good, good. Now we want the people who like exactly two of these activities. I claim that's these 11 people right here, these 6 people here, and these 4 people here. Notice it can't count these folks because they like 3 activities and we said exactly 2. Notice it can't count any of these because these folks like exactly one of those activities and these folks out here don't like any of them. All right. Now I'm going to ask how many like at most one of these activities. This is kind of a foreshadow into where we're going to be heading in this class. We're going to be talking about at least, at most, no more than, and no less than. So translating these sorts of ideas are super important. What does it mean at most one? One or less. So in the context of this, doesn't it mean 0 or 1? Okay, so how many people like none of these activities? That's the 12. And I believe we already said exactly one of these activities, right? We found that already. So we might as well use what we've done. And so what do we get? 76, I can add. Does that make sense to everybody? Awesome, awesome. All right. Well, I am excited to say something. Let me, oopsie, go here. Hooray! We finished up a section, yes. Bike or swim, 58? Yeah, I'm sorry. Thanks for asking that. And I'm happy to go through it if you have a question. Yeah. All right, my friends. So this is what your My Open Math page looks like to you. this is what it looks like for me. We have now completed lesson 1. Okay. Hey, life is thrilling. So if you want to read the book, you got some access right here. If you want some extra video lessons, because this wasn't sufficient, or you feel like you need more, you got them right here. Here is homework. So as I told you, I'm going to do this right in front of your face. So I am going to hit the settings and I am going to assign the homework to be due a week from today, which is September 14th. Now I've noticed that some people already started it. Sweet. But as I told you before, I never expect you to work ahead. Okay, but I feel like I've done sufficient examples to at least get you started. Something else that I want to mention to you in your homework is that oftentimes, but not always, there's little videos that you can watch if you want an extra little tutorial. And if you're working through something and you have a lot of questions, then you want to hit message instruct. Okay, but first thing I want to point out is you have your first homework assignment due a week from today. It's not meant to take you very long. I want you to all do it before next Tuesday night, because I'm just going to keep moving forward. Okay, the other announcement that I have is I had also mentioned to all of you that we have class activities that I like you to work in groups on. Some people don't like working in groups, and I totally respect that. Some people love working in groups so that you can discuss the answers. What I ask is that if you work in a group, you make sure that everybody in your group has a really solid understanding of what's going on. So you're responsible for your own learning, but you want to help other people too. And if you have people in the group who don't understand it as well as you do, it's actually beneficial to you as well, because by explaining it to another person, that's just deepening your own understanding. Okay. Sometimes I allow class time for the group work. Sometimes I hand it out and just give you a little bit of time to work on it in class and then set you free. What I'm going to tell you is for this first activity, we will be doing this in class on Friday. I will send an email out to the class letting you all know. The homework is due by midnight on the 14th. Thank you, Ani, for asking that. Everything's due by midnight. So this Friday, it's going to be an in-class activity. It'll be due next Wednesday when this homework is due. If you want to hand it in early, sweet. But I like to give you sufficient time to get it done. So what I'm going to say is we will not be Zooming on Friday. Okay. I don't Zoom the activities. When we're just doing it for part of a class, I'll Zoom part of the class and then we'll Zoom out. So there was a question of where you can find the activities, and that's an awesome question. And I'm prepared to answer that. I will print out copies for people who come to class, but if you are unable to make it to class, and you're a Zoom student, then you can get it where I'm about to show you. So if you go to our Moodle page, and again, I'm going to send the class an email tomorrow summarizing all these due dates, because I know you have a lot to track and I want to keep us all on the same page. But if you go to class activities, you will find it. I don't think that I have made it active yet. So according to what yours thing will look like right now, you're not going to see it. I have to make it active, which I will do this afternoon. So if you go to the class activities, as I just stated right now, you don't see anything, but I'll have it posted this afternoon. Cool. Again, I'm always happy to help guide you through these things. There's a lot of like, where do I go for this and where do I go for that? So I want to make sure that we're all on the same page. You know, a month in, you're going to be used to all of it, but I get it. It's new systems. Any questions? So we don't have class tomorrow. We have class on Friday, but if you cannot attend class on Friday, if you can't attend class on Friday, just make sure that you work on the activity. So there is another awesome question. Would it be appropriate to have the math lab help us on the activities? Yes, I'm happy to help you on the activities. What I really want to be sure though, is if you go to the math lab, that you don't have them do it for you. Because ultimately you need to be the person to understand how it works. But absolutely, my goal with these things is so that you gain some understanding, okay? The worksheets and activities can sometimes be a bit deeper, and they're meant to involve more discussion, okay? You'll see when you see it, okay? There is no Zoom on Friday. And I will mention this in an email to the class that I sent everyone before Friday. But when I have a day set out for class activities, I don't really see the point of Zooming. And remember, I don't take attendance formally in this class, so it's not like it affects anything pertaining to your grade. Everyone okay? Ish? Cool. Cool. And when I send an email out to the class, I also post it on the Moodle page under announcement. Okay. Is it the case that people don't check their email too much? So one thing that I want to say is all of us faculty, we tend to use email. I know it's a totally outdated thing. And I'm going to start lesson 2 in a moment. We're not done with class or anything yet, but all of us, we're used to email. We really like to use it. So it's really important to check your email regularly because that is how faculty tend to communicate with you. Just a heads up. My son is 20 and he's like, Mom, nobody does email anymore. It's like, well, I can't text all of you. All right. So what I want to do right now, because we still have 15 minutes left of class, and those of you who need to leave early, please leave whenever you need to. Be sure you access the box folder later on so that you can get access to all of this. So this is on tree diagrams. This is fun stuff. You're going to get sick of hearing me, but I'll tell you when I think certain sections are kind of a pain in the side. I'm pretty happy to be honest about that too. Multiplication principle and permutations. Now is when you're going to start wanting a calculator for the class. Again, we have those calculators free of charge for you to check out downstairs in the Missoula College Library. If you haven't gotten one, do it, okay? They're free for the entire semester. It's not like you have to go back and forth. Okay, this is a mouthful, okay? But essentially, the motivation of this section is that we need some techniques to count the number of elements in a set. And you're like, okay, we need techniques to count. Like, we got these awesome fingers, right? The thing is, we are going to have sets. like I said yesterday, with like over 20,000 elements in it. Okay, and we need a quick, efficient way to be able to count those. Okay, so that's sort of the motivation for these next two sections. So what I'm going to do is just motivate it for now with one example. You'll notice that a lot of my examples involve either physical activities, books, music, or food, or cute animals. That's what I think about. So anyway, while we're on the subject, ooh, there is a chat. Okay, so in terms of not knowing how to use the calculator, don't worry about it. I will be showing you how to use, I'll show you how to press the buttons on the calculator, I promise, okay? My hope is that you see that I cover a lot of examples and I try not to leave anything to the imagination. Okay, so let's talk about this. So suppose for breakfast, you could have a bagel, toast, or an English muffin. For toppings, you could have one of the following. You could have butter, jelly, cream cheese, or dry, i.e. no topping. Okay. What I want to know is how many different breakfast choices do we have if we are to select one carb and one topping, I guess I should say, or lack thereof. So we're going to learn a very efficient way of doing this, but we have not gotten there yet. So what I'm going to do is show you one way by drawing what's called a tree. I'm going to just be introducing tree diagrams in this section. Later on in lesson 6, we are going to dive fully into tree diagrams. Okay, we're going to get pretty deep into those. So right now I'm just kind of planting the seed. So do you agree we have two really important choices to make? Yeah, it's food, my friends. Okay, we've got to pick a carb and we've got to decide a topping. So let's first select a carb. Do you agree we have a choice between a bagel, toast, or an English muffin? Have a good day. Y'all with me here? Those are our three choices. Okay. Well, if I pick a bagel, what are my choices? Yes, sorry, Sally. I talk about food a lot. I love to eat. I could have butter. I could have jelly. I could have cream cheese, or I could have it dry. What if I pick toast? Same thing. I could have toast with butter, toast with jelly, toast with cream cheese, or dry toast. And last but not least, how about with an English muffin? Same thing. I could have English muffin with butter, jelly, cream cheese, or dry. Now, the nice thing about this tree diagram is you can look at all your possible choices, right? And we can count them. I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. You agree? By given these options, we could have breakfast for 12 days straight and not have the same breakfast twice. Wow. All right. Well, it's not very practical to draw a tree diagram for all of these sorts of scenarios. So what I want to do is I just want you to notice one thing very quick. Do you agree we had two really important choices to make? Yeah. We had the choice of a carb and a topping. Okay. How many carbs did we have to choose from?
The other question is actually.
Oh, thank you. No, dry is an option. Again, it's a choice of a topping or lack thereof. Okay, it's one of the options that we have for breakfast. If I want to have a dry English muffin, that's a breakfast choice. Thank you. Okay, how many carbs did we have to choose from? 3. How many toppings or lack thereof did we have to choose from? 4. Whoa! 3, 4, 12. What are y'all thinking? Multiply. Wow. Pretty cool, huh? This is going to be really helpful for us moving forward. Okay. I think I have a little more time, don't I? Oh, sweet. Okay. So this is what we're going to be getting at with the next bit of class. What I'm going to do is I am going to right now write out what the multiplication principle looks like formally. A lot of people don't like looking at it because it's a bunch of letters and it kind of vibes people out. But as a math teacher, I have to put it, but I will relate it to how it goes with this example as well as many others. Okay, so if this really like turns you off, then don't look at it. But it's very important that you at least have the general gist. And then what I'm going to do is pick up class. Well, we'll start talking about this again next week on Monday. And I will just do a boatload of examples. And you'll notice the examples get deeper and deeper and deeper. Okay. So we're starting out where we can all access, and then we're going to get a little more involved as we go. But I think it's important to build to that and not dive in the deep end. Okay. So what the multiplication principle, it's also called the fundamental counting principle, states for us is if task 1 can be done in m⁻1 ways, and if task 2, and you don't have to write this down if you don't want to, can be done in m⁻2 ways, and you continue down to all those really important choices you have to make. If task n can be done in m⁻n ways. What this says is then there are m⁻1 times m⁻2 all the way on down the line, ways to perform the task. I won't ever ask you to write things out like this, but let me liken this to our previous example. In our previous example, task 1 was pick a carb. So using the notation here, I had 3 different choices, ways to choose my carb. And fortunately, we only had 2 tasks. Task 2 was pick a topping or not. And how many ways did we have to choose that? 4. Right? We had 3 ways to choose our carb, 4 ways to pick our topping. So what this says is then multiply. Then there are 3 times 4 or 12 ways to do this. You never do breakfast because it's so done. Okay, now we are going to extend this. We're going to get pretty funky as we go, but I'm going to build there slowly. Okay, so don't worry about this sort of thing yet. Well, don't worry about it at all because I'm always here to help. Y'all okay? Cool. Thank you. And you're even getting out 2 minutes early. Oh yeah. Have a great day.